Hey everybody, today in this video we're going to be doing a civil FE exam cram session. I'm going to be doing as many problems as I possibly can in the next hour or so. So if your test is tomorrow, you are in good hands, my friend, because we are about to get busy. We're about to get some problems going. So for those of you who actually don't know who I am, my name is James Huntley. I'm a civil engineer, and I've been helping students to pass their civil FE exam for the past 3 years. So it's been an exciting journey for me, and I love working with my students. And so I'm excited to share this information and video with you. I've been getting a lot of questions about tutoring, and so I do offer personal one-on-one tutoring for students who are looking to pass. The criteria is that you must be willing to put in the work, and we will meet one-on-one, and I will help you, one, navigate the handbook. I'll also give you practice quizzes to ensure that from a time perspective, you are looking good and that you fully understand these concepts. Also, if you are someone who is taking the test, maybe not tomorrow, but within the next 3 to 4 to maybe 8 weeks out, then I definitely want you to check out the 6-week FE Civil Passing Blueprint. This blueprint is going to go over those concepts that you're not having to study the night before. It's going to clearly lay out the concepts with clear solutions and give you tons of practice problems, the right practice problems to be doing so that you actually pass this test with no stress. Now, without further ado, let's go ahead and dive into these problems.
All right, so number 1, this says determine the center of the circle. X minus 3 squared plus y plus 7 squared is equal to 121. So first thing I would do is do a search for circle. Okay, one of the equations that come up says x minus h squared plus x minus k squared is equal to r squared, where the center of my circle is h and k. So I know that h and k here. I'll zoom in a little bit so you can see h and k. So that means I just need to substitute what we have in our equation to what it says in the handbook. So I would do, instead of, I would just set this piece x minus 3. I would set that to equal to what's in parentheses in the handbook. That says x minus h. And so I can determine what h is. I'll cross out my x's, and I get that negative 3 is equal to negative h, or 3 is equal to h. Okay, so that's a part of my center, right? We know that h is the x coordinate. What about k? Well, we do the same thing. We just say that y plus 7 is equal to the same thing as y minus k. And then the y's cancel. 7 is equal to negative k, or 7 is equal negative 7 is equal to k. All right. So the center is 3 and then negative 7. All right, let's look at number 2. Determine the radius of the circle. Okay, similar things here, where we have an equation, x plus 2 squared plus y minus 4 squared minus 40.5 is equal to 40.5. Okay, so in this equation, we're looking for the radius. We know that in this equation that the radius is denoted by r. And so we just have to substitute and figure out how do we get r squared. Because if we know we can get r squared, then maybe we can get r, right? So we have it in the kind of the form that we need it in already, it looks like. So I'm just going to bring over this 40.5 to the other side. So I know that I'm just going to add 40.5. And so I get that equals 81. And so x plus 2 squared plus y minus 4 squared is equal to 81. And so I know that this piece has to equal r squared, right? So if that piece equals my r squared, what I'm getting from here, then r squared is equal to 81. R is equal to 9, right? All right, let's look at number 3. What is the eccentricity of the ellipse? Okay. So I would be looking for ellipse, equation of ellipse. Okay. Nope. Searching through. Okay. So this is under in the mathematics section, but you have a few different cases. You got a parabola, an ellipse for equations of circles, or equations of different types of functions. You have parabola, you got an ellipse, you also have um, a hyperbola, and you have a circle. Right, so we're looking at the ellipse, and we're looking for the eccentricity. So eccentricity is denoted by, it looks like E is equal to the square root of 1 minus b squared over a squared. And so now we just need to determine what b and a are, or what c and a are to get E. Okay, so we have, let's look at our equation. Looks like we have an x squared on top, right? So we got this x squared. So I know that this is x minus 0 squared all over 16 y minus 0 squared over 4. All right. So I know that according to this equation here, that x, or I know that h is going to be equal to 0, and I know that k is equal to 0. Right? But we are looking for b and a. Right? So a squared is shown at the bottom. So this represents a squared. So a squared is equal to 16. And so now we know that a is equal to 4. Okay. And we know that this piece is equal to b squared. Where am I getting that? Getting it from here, b squared. All right. So b squared is equal to 4. So b is equal to 2. Okay. So now I can solve for e. For e, we get e is equal to the square root of minus my b squared, which is 2 squared, all over 4 squared. Right? And for that, I end up getting 0.866 for the eccentricity. All right, let's go to 4. Okay. You can kind of see this. Okay. So number 4 says a line goes through 0.26 and is perpendicular to line 4y plus 2x plus 18 is equal to 0. Okay, solve the equation of the line. All right. Well, I feel like there's an important thing that you need to know for this. How do you know how to get something that is perpendicular to a line? We do a search in the handbook for perpendicular. It lets us know. I'll stretch this over just for a second. It lets us know that two lines are perpendicular if the slope 1 is equal to the negative 1 over m2. So that means that for lines that are perpendicular, for the first slope, you need to get the negative inverse of that slope in order for those lines to be perpendicular. So let's dive into it. So first step we need to do is get the slope of the line, of this particular line that we have. So we know that our function is going to be 4y plus 2x plus 18 is equal to 0. Okay, and we need to get this in standard form. And so we're just going to say 4y, we're going to start moving stuff to the other side. So 4y is equal to negative 2x minus 18. Okay, then we just need to get y by itself, right? So y is equal to negative 2x over 4, which is divided by 4. That's 18 over 4. And so we get the slope here to be a negative 1/2. We know that this is the, let me denote it by something, a different color so you can kind of see. All right. So I know that the slope of this particular line is going to be negative 1/2. So I know the slope of my perpendicular line needs to be the negative inverse of it. So I know that the new slope needs to equal the negative inverse. So what's the negative inverse? So I know that we'll just say negative 1/2. Drawing all types of squigglies. Negative 1/2 translates to, well, we know that the negative part of this, so a negative 1/2 is just going to be 1/2. So that's, we took care of the negative piece. We still also need to do the inverse. So I know that it just, if I flip it, it equals 2. So the negative inverse is going to be 2. So that's my new slope for this line. Okay. So now we need to use point slope because we have a point. We know our new slope, and now we can find the new equation of this of this line that's perpendicular to the function. Okay, so we do this by saying we can use the point slope form here. You can see. Okay, so I would just do y minus y1. So let's come over here. So y minus y1, which is 6, is equal to my should be m, which is going to be 2 times x minus x1, which in this case is 2. So we have y minus 6 is equal to 2x minus 4. Okay. And then we should end up getting, we'll add 6 to both sides. So we get y is equal to 2x plus 2. And that is our equation for a line that is perpendicular to this equation. All right, let's look at number 5. All right, so this one says, what is the cross product of the two vectors? A is equal to 3i plus 2j minus 6k, and vector B, which is going to be equal to I minus j plus 4k. Okay. So how do we do cross product? Well, we just do a quick search in the handbook, cross product. Okay. And this is kind of what it looks like, but the handbook doesn't really help us a ton here. So you're just going to need to have remembered how to do cross product. So we'll do A cross B. So we'll put them, just list them out. 3i plus 2j minus 6k. And then this is on the bottom, we'll put our B, which is I minus j plus 4k. Okay. Now, the next thing we need to do is find our I. So to get I, we have to cross this one and this one. So we would get for I, we get 2 times 4 minus a negative 1 times a negative 6. Okay. And so for that piece, I get 2i. Okay. The next piece of this is we need to get our j piece. So we're going to be, for that piece, we're going to be doing 3 times 4, and then minus a negative, it's going to be minus I times a negative 6. Okay. And so you have to remember for your for your j component rather, you always multiply it by a negative 1. Something that you just have to remember. So for that component, I end up getting a negative 18. And for our k component, we're going to do the same thing. So this is I. Just going to separate these out. I. This is our j component. And then we're now doing our k component. All right. For k, we're going to do 3 times a negative 1 minus 2 minus and a 1 times a 2. And so for that, we end up getting, I get negative 5k. All right, so what is the cross product? We take all of these and place them together. So the cross product is going to be 2i minus 18j minus 5k. All right, you have to get all the components, put them together, and you are good to go. Alrighty. Let's look at number 6. All right. So this one says, what is the angle between the two vectors? Okay. To get the angle between two vectors, you can do a few different ways. You'll need to go to your handbook and go to the vector section. And so what is an angle for vectors? So it's denoted by theta. And so we know that if we can find the dot product, which is just ax times bx plus ay times by plus az times bz, we can also get the magnitude of a, the magnitude of b, and we can solve for theta. Now you could also do this with the cross product by doing the cross product of a and b, getting the magnitude of a and b, and then doing the sine inverse to get your theta. But I like dot product, so I'm just going to do dot product. Okay, so you're going to want to know how to do that. Not really enough room here. So yeah, maybe I'll just put this. So first we're gonna do dot product. So we're gonna do u dot v, which in this case u dot v is equal to, it's gonna be our first variable. Don't want you to get confused. U dot v is ax times bx. So our ax this, or in this case you just want to substitute it for u and v, but our version is 8 and 2. So we would just do 8 times a 2. And then the next component of that is going to be ay, by. That is this. So we would say plus 3 times a negative 1. And then the last component, the negative 6 and the 5. Then we're going to do it's going to be minus 6 times 5. All right. I'm going to use some regular colors here. So when we total all that up, we end up getting this is going to be 16 minus 3 minus 30. Okay. And that totals to negative 17. Okay. And so now we want to get the next piece of this. So we got our A dot B. So we're able to do A dot B. So we need to find A magnitude and B magnitude. So basically what we're saying is cross product dot product is equal to U magnitude V magnitude cosine of theta. All right, how do we get U magnitude? U magnitude. Well, to get U magnitude, or any magnitude, it's just going to be x squared plus y squared plus z squared all over the square root. Okay. So we're gonna go ahead and do both of those. And maybe I shouldn't erase that. So magnitude is equal to U. U magnitude is going to be equal to x squared plus y squared plus z squared all over the square root. Okay. And that's for all of these different U components. And then V is going to be the same kind of thing. V magnitude is going to equal to the square root of x squared plus y squared plus z squared. All right. So we gotta find the magnitudes and multiply them together. So what it looks like is this. So we're gonna just say equals. So it's gonna be a big kind of long formula. So I'm just bringing everything over. So negative 17 is equal to, in parentheses, we'll do our U magnitude. So it's the square root of 8 squared plus 3 squared plus a negative 6 squared. Okay. And that's my U. Now we're going to do our V. So it's all over the square root of 2 squared plus a negative 1 squared, and then plus a 5. Already. And so when we do that, this is this component, this is this component. And then we got to remember cosine theta. Okay. So when you put all that in your calculator, you're going to get should get negative 17 is equal to 57.18. So I just multiplied my U magnitude and my V magnitude to get that, and then I still have cosine theta left. All right. And so now I need to do negative 17 divided by 57.18 is equal to cosine theta. And so I also need to go ahead and transfer this to say that theta is equal to get rid of that cosine, you need to do cosine inverse -17 divided by 57.18. And when you do that, you are going to get, or you should get, 107.29 degrees. If you don't get 107.29, then it means you probably need to change your calculator from radians to degrees. Excuse me. All right. So let's look at number 7. All right. So we had all right. So now we're just doing dot product. So like we saw in the handbook, dot product is going to be listed here. You just search dot product and you'll find this equation. So pretty easy one here is just going to be ax times bx plus ay times by plus az times bz. Okay. So remember that equation. See this? All right. So basically we want to do t dot s, and that's going to be the dot product, which equals 1 times 9 plus 5 times 3 minus 5 times 2. And so you're going to get 9 plus 15 minus 10. And all that should equal 14. So pretty simple there. All right, let's look at number 8. Number 8 says solve for the x-intercepts of the second derivative function, x to the 4th plus 4x cubed minus 18x squared. Okay, so what is an x-intercept? An x-intercept is where x-I-N-T is where y is equal to 0. And so pretty much if you have something drawn, so you had a crazy equation, the x-intercepts are going to be here, 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 here. This means y is equal to 0, right? All right, so how do we get that? Well, first of all, we got to figure out the second derivative, right? So if you don't know how to do derivatives, you got to make sure you know how to do those. You kind of have to remember how to do them. Maybe you can use the handbook. Mathematics. Zoom out here. And I'm going to search derivative. Okay, so they do give some definitions where they say that the derivative for any function, the y prime is equal to the slope of the curve. But they don't really. I think there may be some derivative. So, yeah, the handbook just really doesn't help us here. And so you just need to kind of know how to take the derivative of function. So, let's do it. All right, so x to the fourth plus 4x cubed minus 18x squared. Right, so this equals y. So the first derivative is going to be y prime. So we're going to carry over the 4's. It's going to be 4x cubed. And this is me taking the derivative. Plus 12x squared. And then minus 36x. Okay, so that's y prime. And so y double prime, because we're taking the second derivative of this, is going to be 12x squared plus 24x and then minus 36. Okay. Alrighty. And so now I think we can factor some of this stuff out and see if we can get some values for x, for y to actually equal 0. So everything that I see that this equation has in common is 12. So 12, I want to factor that out. So I'm just going to get 12 Okay, so 12 times x squared, and then plus 2x, and then minus 3. Can I factor this down anymore? What can I add together to equal 2 and multiply together to get a negative 3? Well, I can do x plus 3 and an x minus 1, and that'll give me what I need. Okay, so now what can I plug in for x to make this second derivative equal to 0? Well, I know if this piece equals 0, then the whole thing equals 0. So if I plug in x is equal to negative 3, then I know that the whole function is going to equal to 0. Or if I plug for this one, x is equal to 1, I know that goes to 0, and now my whole function is equal to 0. So those are going to be my two x intercepts for the equation of the second derivative. All right. Number 9. Does the equation equal 1? Okay. So I'm going to look at see if I can use the handbook for some of this stuff. Does the equation equal 1? Sine squared of theta plus cosine squared of theta. So there's some identities in the handbook. Where you can take a look and see what is true. So sine squared plus cosine squared. Sine squared plus cosine squared does in fact equal 1. So I would get yes for this. All right, let's look at number 10. Does the equation equal 1? Okay, secant squared plus tan squared. So is there any relation between secant and tan? Okay, so I see secant squared plus 1. Tan squared plus 1 is equal to secant squared. Okay, so I'm just going to rewrite that so I can fact check this. So they're saying that secant squared plus tangent squared is equal to 1. And I'm going to see if that's true. So tangent squared theta plus 1 is equal to secant squared of theta. Okay, so secant squared of theta minus tangent squared of theta is equal to 1. So it's not plus secant. It's not secant squared plus tangent. It's secant squared minus tangent, which is different. Which means that no, this does not equal. Okay. All right. Let's look at number 11. It's kind of hard to see. All right. So this says find the mean and variance of the data. Okay. All right. So the following represents how many shots LeBron took in the postseason from 2019 to 2025. All right. So in 2019, he took 1,800 shots and so forth. So this is our given information. We want to find the mean and variance. Mean just means the average. So if I want to find the mean, I know that I need to add all of these shots up and divide by the number of years, right? So looks like it's, if I just go through, that's 1, 2, 3, 4, 5, and 6. So 6 years. And I know that he took um, all these different shots. So we're just going to go through, add them up. So we'll do 1,800 plus 1,287 plus 497 plus 122 plus 224 plus 0 all over 6, right? This is just taking the mean, the average. So when I do that, I am going to get, this is going to equal to 838.33 shots. All right. So I'm just going to say that's approximately 838 shots. Right? Can't have a third of a shot. All right. So next thing is going to be me finding my variance. How do I get variance? I'm going to do a search. Okay. So this says that the variance of the population is going to be denoted by sigma squared. So sigma squared is equal to, I can write this down, right? And I'm going to erase our average. We know that we do need to know the mean. So the sigma squared, which is our variance, is equal to 1 over n times x1 minus. Okay, so what's x1? That's the value of the observation. Okay, so x1 in our case for 2019 would be 1,800 shots. And so minus that mu, which is the arithmetic mean, which means that it would be, our mean in this case is 838 shots. Okay, and we want to do that squared. Okay? And we want to do that for all the numbers, right? That's what this is saying. So you want to do it for x2, x to the n. So x3, how many of them it is? So in our case, we have 6. All right. All right, so we're going to do that for each one. We're going to say 1 over n. So we're going to say sigma squared is equal to 1 over n, which in our case is 1 over 6. N equals 6 times x1. X1 is 1,800. This is going to be a long one. So 1,800 minus 838, which is our mean. And we're going to square that. And we're going to add it to the 1,287 minus 838. Square it. All right, we've done that one. Now we're going to add our 497 minus 838. Square that. All right. I'm going to continue this in parentheses. Plus, we've done that one. Our 1,222 minus 838. And we'll get that squared. And then we want to add 224 shots minus 838. And we'll square it. And then we want to add our 0. 0 minus 838. All that squared. You can see that I squared it. All right. Now all that's in parentheses. And we're going to get for our answer, when you add all that up, you should get 411,670.33. So that is our variance here. Now variance just means how much does the data vary, and it varies a lot because one year you make no shots, and then another year you make a ton. So, all right, let's do number 12. All right, so for this one, how large of a sample of townhomes would be needed to estimate the population mean within plus or minus $75 with 80% confidence? Okay, the standard deviation is 145. So for this type of problem, this is data and statistics, and so 80% confidence lets me know that this is a confidence interval type problem. and we know our standard deviation. So in the handbook, it goes over some confidence intervals with a known standard deviation, right? The known standard deviation. So it's just basically saying that, hey, we want to do plus or minus. This is the plus side. This is the minus side, and this is the plus side. The $75. Right? That's our bounds. We want to see, can we be 80% confident? All right. So we're going to look at this lower bound. All right. So we'll just say, this is an important formula to remember is here. We just want to look at this side of the bound. So we're going to say that x bar is equal to x bar minus my z alpha over 2 times my standard deviation over the square root of n. Right? Okay. So we're trying to find that particular bound. And so we know, so what does it say? This is equal to 0. And so do we know x bar? Well, x bar in this case is going to equal to 75. Right? That's population mean. And then z alpha over 2 is going to be what? Well, we need to know, well, they say it needs to be 80% confident. So in this case, there's a table that goes over for confidence intervals that shows how confident a value for z alpha over 2, depending on the confidence level. So here in your handbook, you can pull your confidence interval for 80%, and you're going to get roughly 1.28. So I'm just going to say is equal to 1.28. Right. Next thing we need to know is what is sigma, or not sigma, but this, whatever that is. That is going to be equal to the standard deviation, right? Same symbol. Standard deviation symbol is known. Okay. So we know that that's equal to 145. Okay. And n is what we're solving for. All right. So now we have everything to solve. So we will say that 75 is equal to 1.28 times 145 all over the square root of n. All right, the square root of n, I'm just shifting, multiplying it over, and dividing to get it to separate it from everything else. I'm going to say 1.28 divided by 75 times 145. All right. And so this, now I'm getting that n is going to equal to 6.12, or approximately 7 townhomes. So we need a sample of 7 townhomes, we need to estimate the population mean within plus or minus $75 with 80% confidence.
Hey, I hope that you're enjoying this video so far. I just wanted to hop on here and share that you are not alone as you're studying for this Civil FE exam. Now, you may have gone through this video and have noticed I don't feel like I'm able to find the correct formulas from this 502-page handbook, or you're just not using the correct search terms, or it's taking you way longer to do a problem than you feel like it should. And if this is you, I would encourage you to download the Civil 6-week FE Passing Blueprint. It's really going to help you understand concepts, be able to navigate the handbook, and be able to do problems much faster than you typically would. But you may be wondering, hey, what about if I need more of a personal one-on-one kind of tutor to help me make sure that I'm doing the right things and that really gets me the results that I want? And so if you are looking for a tutor to help you study for this test, and I wanted to let you know that I actually do work with students one-on-one to help them pass. Now, I do have some things that I'm looking for as I'm selecting students to work with. I definitely have to have someone who is hardworking and that is willing to show up on time and that is hungry to pass this test. When you win, I win, and so I really want to be working with students who are serious about this. So if this is you and you're interested in working with me one-on-one, then you can apply by checking out the links down in the description box below. Now, let's go ahead and get back to the video.
All right, let's look at number 13. This Baker buys a house for $115,000. He pays a down payment of $35,000 and then receives a loan from the bank for the rest at 4% for 20 years. Solve for the required yearly payment for the loan. So we're trying to find annual or A terms. I need to draw out kind of my time value of money scale. Okay, so Baker goes in the hole, down 115K, right? 115,000. And then he pays a down payment, so he got rid of some of that by paying 35. Okay. All right, balance some of it out. Okay. And we want to know what is the required yearly payment for 20 years. So I know that at year 20, this is at 0. There are some payments that are going to have to happen, right? And we just want to find what that yearly payment is. And it's the same payment each year for 20 years. And so we know we want to turn all this into the present worth. So we want to find A given P. So first, before we jump into that, we know that our interest rate is equal to 4% a year. We know that the number of years is equal to 20. Right. We also know that our present worth is equal to 115 negative 115K plus 35. So we're down how do we make up that 80,000? All right, so we want to find P given I meant find A given P. So in the handbook, I would just go to the bookmarks section, go to engineering economics. It should be there. And then that puts us in the section that we need. So we could use factor tables to do this, or we could do this by hand. So I am going to see if we have factor tables for 4%. So we do have it for 4%. And we want to find P, or we want to find A given P. So 2A given P. We know that our N is going to be 20. I get my 20 value to be this, and you can't see that. So I find going 2A given P for N of 20 years, and so it matches to 0.0736. All right. So to get this, we're just going to do negative 80,000 times 0.0736. And so it's each year you're going to have to come out of pocket, spending about $5,888 per year to be able to pay that back after 20 years. Okay. Alrighty, let's look at number 4. All right. This one says Ferrari buys a basketball facility at $35,000. She pays the down payment of $7,000 and borrows the rest from a private loaner at 6% for 8 years. Solve for the required quarterly payment for the loan. Alrighty. So for this one, I'm going to draw this out again for time value of money. All right. Down 35K. And then she did make a payment for 7K. Okay. And so she had to borrow the rest. So we know that 6%. Okay. Quarterly payment. So we're looking for quarterly payment. So we know that this 6% per year, if we divide that by 4, if we do 6% divided by 4, that gives us the quarterly interest. All right, so when I do 6%, 6 divided by 4, all right, so I get 1.5%. Okay. And so now we also know that the N value, or the number of quarterly payments, is different from the number of yearly payments. So we want to solve for the quarterly payments. So we still have a value, right? A value is just a uniform amount, and in the handbook it gives you the definition of what A means. 2A is just the uniform amount per interest period. So we're still looking, we're trying to get 2A given P, but we need to make sure our n value is correct. So n is equal to, in this case, it's the number of compounding periods, and our periods is going to be it's 8 years. This is year 8, and this is year 0. And so since it's 8 years, we want to do 8 years times 4. It's going to be actually 32 quarterly payments. Okay. So now we have our N, we have our I. Okay. So we have our I. Anything else? Well, we need to go to figure out what our conversion factor is. So I'm just looking to see if there's a 1.5%. There is. So we want to get to A given P. What is our P, by the way? Our P is just going to be negative 35 plus 7. And it's 7,000. So we'll put K beside them. And that is going to be equal to negative 35 plus 7 is going to equal to 28K. All right, so let's look at this, our factor to multiply that by. Well, if we do 2, we're trying to get 2A given P. So 2A given P. We need it for 32. And it needs to be 32. So unfortunately, they don't give us our value. So now we're going to need to be able to do it by hand. This is the only time that you would be doing this by hand. And so these are our conversion tables. We just need to figure out which one we're using. All right, so we want to get 2A given P. So this is the A given P. This is the equation that we want to use. It's going to be I times 1 plus I to the n over 1 plus I to the n minus 1. So it's I represents, of course, our interest. N is the number of compounding periods, and then that'll give us that conversion. All right, so hopefully you take a picture of that, or maybe I can still have it up. So to be able to do this, we're going to, this is how we'll do it. I'll just plug it in and go, we got our 1.5 divided by 100. That's my I. Okay. Times, and I just break this up in pieces. 1 plus 1.5 divided by 100. Okay. To the n power of what? What is my n? My n is equal to 32. So to the 32nd power. All over 1 plus 1.5 divided by 100, okay, to the n, so the 32, and then minus 1. All right, and so when you put all that in there, top should be 0.024 over 0.610, which gives you a total of 0.03957. Okay, and so now that's our conversion factor. So that's the number we need to be multiplying by 28,000. Right? So we go ahead and multiply it by 28,000 or 28K times 0.03957. We end up getting our quarterly payments, and that is equal to $1,108.15. All right. All right. So that was number 14. Look at number 15. All right. So for this one, so Chandra borrows 22,000 to start his own business in Aruba. Determine the interest rate if the future value is 31,000. That should be 31,000 over 6 years. Let's take a look at this. So I know that I'm trying to get to the future or determine the interest rate if no. So I borrow, so I'm trying to get I have the present and I'm trying to get to the future, and I have the interest rate, or I'm trying to determine the interest rate over 6 years. So I know my n is equal to 6. I know that my p is equal to 22,000, and I want to find my I. So I know that I also have my future, which is 31,000. All right. And so we know that if we take our present and multiply it by our conversion factor, then we can get it to the future, right? All right. So if we take that approach, we can find the interest rate here because we know that the conversion factor is going to be a value that we can solve for. So what is our conversion factor? Well, let's just take a look at it. If we have P and we're trying to get to F, then we can just use this top one here. 2F given P, we know that that conversion factor is 1 plus I to the n, right? So P times 1 plus I to the n is equal to F, right? And so that means that 22,000 times 1 plus I, which we're solving for, to the 6th power. We know what n is. is equal to 31,000. Now, how do we get further in this? So I know that we can divide by 22,000. And we can say 1 plus I to 6 is equal to that. Okay, so how do we get rid of this 6 power? Well, if you were to say x, we'll just take an example. X squared is equal to, we'll say 81, all right? And I know to get rid of this, I need to take x is equal to 81 to the 1 half. So I basically just need, and that is the same thing as x is equal to the square root of 81. It's all the same thing. This value is just equal to, is 2 there. Now, in the case where we have x cubed is equal to 81, we would just say x is equal to 81 to the 1 over 3. Okay? Or this is the same thing as saying the cubed root, I think that's how you would say that. Okay. So now that hopefully you understand that, you know that 1 plus I is equal to 31,000 over 22,000. Put that all in parentheses, all to the 1 over 6. Okay. And then we'll just subtract 1 from that. And that should give us our answer. So when we do that, we get I is equal to, slide this over. I is equal to, and let me make sure I was writing, but I don't think you saw that. So let me go over this one more time. So in this case, if we were to look at x squared is equal to 81, we know that this is the same thing as saying x is equal to 81 to the 1 over 2, or x is equal to the square root of 81. Okay. In the same breath, if we were to look at x cubed is equal to 81, we would say that x is equal to 81 to the 1 over 3, or that x is equal to, okay, so that's the same thing. So knowing that, now we can solve our equation, right? So how do we get rid of that 6, or that 6 power? We can say that 1 plus I is equal to 31k, 31,000, but about 21,000, all to the 1/6. Okay. And then if we just subtract 1, both sides, get rid of that. And that's what I is equal to. So I ends up totaling to 5.88%. Okay. And you probably got a decimal. This would have given you a decimal, which would have been 0.0588. You have to multiply by 100 to get it in percent. Okay. All right, let's look at number 16. Alrighty. So this one says for number 16, the depreciation value for a truck is 8,800. Okay. Determine the lifespan of the truck in years if the truck was purchased for $65,000 and the salvage value is $12,000. All right. Depreciation. Just gonna do a search for depreciation. Okay. And all right. So for this, it says dj is equal to c minus sn over n. And so c is the cost, sn is the salvage value. You can find this expected salvage value. And then n is the number of years. All right, and dj is the depreciation cost. Okay, so we know that if we use this, we would say dj is going to be equal to my c minus sn all over n. Okay. dj is equal to, and so I'll just I'm not gonna write each individual variable out so you can follow. So I get 8,800 is equal to 65,000 minus salvage value of 12,000 all over n. Now, when we solve for n, we get 6 years. All right. Let's look at number 17. Okay. Jazz deposits 3,000 in a high yield savings that gives 4% interest compounded annually. The money she will receive in the account after 12 years. So how do we get this? Well, we're trying to get to f given p, right? Where we know that I is equal to 4%. We know that n is equal to 12 years. And p is equal to 3,000. We just need to find our conversion factor, right? So if we use conversion tables, or see if we can use the conversion tables, and we're looking for 4%. Found the 4%. Now we just want to see where n is 12, and we're trying to get to f given p. And for 12. And so for that one, I get 1.601. Sorry, 1.6010. There. Zoom in so you can kind of see. All right. So I'm just going to use that for this. So 1.6010. And for my answer, when I multiply 3,000 times that, I get 4,803 approximately dollars. So after 12 years, she put in 3,000, didn't add any more to it, and ended up being $4,803 after 12 years. So it grew. Alrighty. So a cameraman has a total cost of $300,000 per year, including rent costs and any depreciation costs. Each camera costs $47 to make. Each camera sells for roughly $250. How many cameras will it take to sell to make at least $1,000 in profit? Okay. So this is a type of problem where you have to write out your equation and kind of figure out at what point you can make money. So just like you would do, let's say you're working a job, right? And you know that you make how much ever you make per hour, you would be looking for how many hours it would take for you to reach a certain savings goal or a certain amount in your bank account, right? So similar with this. So imagine you know that you're starting out with the cost of 300,000 to start. So you just something like this. You create your equation. So you know you're down 300,000 regardless, right? And then you know, and this is just for the factory cost, right? Rent, fees, depreciation, all that stuff. And then you know that each camera costs $47 to make, so that doesn't include the cost of the camera to make it. So you know that minus $47 times the amount of how many ever cameras that you're selling. And then you know that you're going to be able to sell it for $250. So plus 250 times the amount of cameras. And you know that you want all this to equal $1,000 in profit. So it would be zero if you wanted to break even, right? But you're just taking it into account all your costs. So when you total this up, you end up that 250 minus 47 is going to be so it's going to be 203x is equal to 301,000, right? And so x, or the amount of cameras that it would take to sell, would be 1,483 cameras, roughly. That's where you're going to make that $1,000 in profit. All right. Let's look at number 19. Oh, this one says, what is the annual effective interest rate of money that is invested at 2.5% compounded monthly? Okay. So, annual effective interest rate is going to go to the engineering economics section of my handbook first to start. So, engineering economics. Here. All right. All right, and then I want to search for annual effective interest rate. Do a search. Uh, I think IE is annual effective interest rate. Okay. And so from there, we know that, so we're looking for 2.5%. So, and it's compounded monthly. We're trying to find the annual effective interest rate, money that is invested at 2.5% monthly. So this is going to be, I'll just write this out for us. I is I sub e is equal to 1 plus r over m to the m minus 1. So that's our equation for this. So we're looking for I sub e. Right? We're looking for this term. Do we know r? R is nominal annual interest rate, 2.5%. Okay. So R is equal to 2.5%. And then we know that M is going to equal to the number of compounding periods per year. So if it's compounded monthly, per year is 12 monthly. So now we plug this in and see what we get. 1 plus 2.5 divided by 100 divided by 12. Then that's all to the 12th power. And then minus 1. And so you should get to roughly 2.53%. All right, let's look at number 20. All right, so this one says the ropes shown below are holding a $1 million briefcase that weighs 800 pounds. What is the tension force in rope 1 and 2? And the system is in equilibrium. So we want to find what forces are acting on 1 and 2. Okay, so we got to draw this diagram. So we have, to be able to pull this up, we know that the force acting here is coming kind of this way. And then we know also that there's some force being pulled upwards and to the right. All right. So what I'm looking to do is to try to figure out how I can draw something that will get me to free up a variable to where I'm not having to solve for two variables at the same time. So I got a force coming down, right, in the y direction. And I know that this is in the x direction, so I know both of my forces have forces in the x direction, but only one force has force in the y direction. So I'm going to do the sum of the forces in the y. So I get negative 800 pounds. And I know that this force is going upwards and to the right. So it's going to be plus T1. So I know that we're just trying to find the y component of this. So in order to do that, you need the force times its y component, which in this case, to be able to get that, you have to do T1 times the sine, or the opposite. So this is the opposite over the hypotenuse, which we don't know. So how do we get that? Well, the opposite is just going to be 5 over the hypotenuse, which is just going to be the square root of 4 squared plus 5 squared. And so now that gives us T1, which now T1 we get to be 1,024.5 pounds. All right, so now how do we get T2? Well, now we can do the sum of the forces in the x direction, which is going to be I got a force going to the left for T2, so that's a negative in x, negative T2. And then plus my T1 times, instead of sine, we're going to do cosine. So cosine is going to be adjacent, which is 4, over the hypotenuse, which is square root of 4 squared plus 5 squared. And so now when we substitute, we know that that's T1 can turn into a 1,000, can turn into that value, right? 1024.5. Okay. So now what we can do is we can get our answer. So we'll get T2 on one side, and once you do the math, you should be able to get T2 is equal to 640 pounds. All right, so that is the force in rope 1 and 2. Let's look at number 21. All right, so this one says, what is the roller support reaction that occurs at joint B? Okay, so good to draw a free body diagram here. So you got a pin at A, means you have an AX and an AY. These are your reaction forces. And then you have one reaction at BY. And so it's asking us to determine what the reaction at B is. So we're trying to get BY. So if to be able to do this, we want to, if we try to do some of the forces in the Y, it's not going to help us out because we'd have some of the forces in the Y is equal to an AY, which is an unknown, minus a 700 plus a BY. So now you got two unknowns. So what we want to do is we want to take a moment to get rid of some of those unknowns. I'm going to take a moment at A. So that gets rid of AX and AY. So we'd have the sum of the moment is equal to a negative 700 times its distance of 9 plus a BY times the distance of 12. And so when we solve, we get BY is equal to 525 pounds. All right, so not too bad there. How many joints are there in the truss? We count joints like this. So anything that's the connection point. So 1, 2, 3, 4, skipped 1, 5, 6, 7, and 8. All right, pretty simple there. How many members are there in the truss? So that is the sticks between the joints. So I'm just going to go in here and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. All right. what is the axial load in EH? If I was to do this problem and I started here, if I do the sum of the forces in the Y component, I would know that it's going to be 0 plus EH. And so therefore, EH has to equal 0. And so, yeah, if you're just drawing, if you're doing method of joint, right, you have to draw it out. So there's no other forces acting on the joint outside of, you got your HB, you got your GH, and then you have your EH. But you know that has to be equal to 0, so EH has to equal 0. It's the only force acting in that direction. So EH is equal to. All right. Find the centroid of the shape. To be able to get centroid, use our handbook. We'll do a search for centroid. Okay. And centroid of area here is going to equal the moment of area over area, but that may not help us here. Or is equal to the sum of xn times an over a. So xn is the distance from the centroid, or the center of the shape. And an is the area of the shape. And then a is the total area. And so here I can look at this and say that we want to split this up, and I'll write the AC. So we'll do X AC, and we'll say XAC is equal to the sum of X sub n times A sub n all over A. All right, and then Y AC, centroid of the shape, the sum of Y sub n A sub n all over A. Okay. So let's start with this. So XAC is just the X component of the centroid of the shape. So we got to find X sub n to start. So, but first we need to find what are our shapes. So I'm going to say that we got shape. So shape 1 is the rectangle, and then shape 2 is equal to the circle. And what we'll do is we'll subtract shape 1 from shape 2. We'll be able to get all the values that we need. All right. So let's find our x coordinate. So we'll look at shape 1. We'll say for shape 1, that the x sub n from here to here is going to be, I would say, the halfway point of this rectangle, just the rectangle, is going to be 5. So that's our x sub n. All right, so we'll say for shape 1, we'll say 5. And then we want to multiply that by the area of the shape, which is just 10 times 6. All right. And then, so we're doing the sum of x n's. So we need to look at shape 2, right? So we're going to subtract. All right, so where is the center of the x component for the circle? Well, looks like it's here. I'll use a different color. It's at 3. So we'll say minus 3. That's my x sub n. And then what else goes along with that, right? 3 times my area of my circle, which in this case is going to be pi r squared. What is the radius of this circle? Well, it's just half of the diameter, right? Which is 2. So I know that my radius is going to be 1. So pi 1 squared. Okay. And so we're taking the sum of that all over the total area. So the total area is just going to be your 10 times your 6. It's just the area of your first shape plus the area of your second shape. In this case, we have a hole, so this you're going to be subtracting some area. All right. So now for that, I end up getting this totals to 5.11 for my x, and this is XAC. Okay. So you can imagine that it's that 5.11 is probably hitting maybe here, right? So it's just a hair to the right. All right. And so now we want to find our YAC. So we go about it the same way. We first find the center between here and here. So the center between 0 and 6 is going to be 3. For our rectangle, 3 is y sub n times 10 times 6. Right? And then what is the center? Where is the center? The y component for the circle. Well, it's also at 3. You just look over. That's going to be the center, so 3. All right, so minus 3 pi 1 squared, and that's what our a sub n is. It's the area of our circle. All right. We take that and we put it all over the area, which is again going to be 10 times 6 minus pi 1 squared. And for y, or this the y component for the centroid of this shape is going to be equal to 3. All right, so it's going to happen at 5. We'll call this little point 5.11, and we'll call this little point 3. So 5.13. So it makes sense, right? That's where the center. It's not drawn to scale because this would literally be. It may be a little bit more inside of that circle, but kind of get the gist. So that is a centroid of the shape.